Well, hello, good morning, good afternoon. I'm Brian Reed from NowSecure, and I will be your guide on today's session, Top OSS for Mobile App Security Testing. Our live webinar today has a very high number of registrants, so we're going to give people time to get logged in and up and running. It's right at the top of the hour, so we will start in approximately 1 to 2 minutes while we await for other people to join. So once again, thanks for joining us today for our webinar on FRIDA, Radare, and more. And we'll get started in just 1 to 2 minutes as people continue to join. All right, once again, if you're just joining us, we're going to be starting our webinar on FRIDA and Radare here in a minute or two. We have a large number of registrants. We want to make sure everybody can get in before we get rolling. We do appreciate you joining us today. We're excited to have some of the best mobile app security researchers and reverse engineering guys on the planet. And we're going to have a great session here hearing the latest on R2 and FRIDA. So hello again, everyone. My name is Brian Reed. I'm the Chief Mobility Officer here at NowSecure. We're excited to have you join us today for our webinar, Top Open Source for Mobile AppSec Testing, the latest on R2 and FRIDA. Today's session will be hosted by me and led by some of our great members of our NowSecure Research Team. I want to go through just a few notes before we begin. So today's session will include both a presentation with demo and a formal question and answer session at the end. At any time during this webinar, you can ask a question using the Ask the Question tab in your BrightTalk webinar screen on the right-hand side. Enter those questions, any questions you have as they occur to you. We will collect all the questions and we will answer as many of the questions as we can at the end of the session. Second, today's presentation will be recorded, and we will be sending a follow-up email to all of you that will include a link to the recording and to the slides as well, so you'll have that for further follow-up yourself and within your organization. And third, when the webinar is over, you'll see a ratings section on the BrightTalk screen right at the end. We'd very much appreciate if at the end of today's session you would rate today's presentation. This helps us make sure we're providing helpful, relevant content to you in the future. I will remind you we do these webinars every month and the topics rotate over time. So as we jump into our session here, I just wanted to get us started on why we're here in the first place. And we're here because of mobile app risks. Could someone else advance the slides? Back one. It appears I'm having a technical issue advancing the slide. So we're here really to talk about why mobile AppSec testing matters and why tools like FRIDA and Radare are so useful. And the reality is that the majority of mobile apps have one or more vulnerabilities in them. And whether you're on the reversing side or the app security side, finding those issues, those vulnerabilities, and patching them and filling them before you go live is what really matters. Now, if you're joining today, you're probably joining because you have an interest in mobile app security, and we'd encourage you to sign up for our weekly newsletter. Every week, delivered into your inbox are 5 or more newsflash items on the latest develops around mobile app security, mobile app testing, and so on and so forth. So we have thousands and thousands of readers. We encourage you to sign up for this. This will help you stay in touch in one place to get all the latest news around mobile app security and mobile app testing. So with that, I'd like to introduce our agenda and speakers. So we're going to focus on FRIDA and Radare today. So From the research team, we have Dave Weinstein, our leader and CTO. David will introduce himself, and he'll be the next speaker. After David will be Sergey, otherwise known as Pancake. He's the creator of Radare2, also a member of our research team, and is going to show us the latest with Radare and how to take advantage of Radare. And then finally, last but not least, Ole will speak, and he's the inventor and creator of FRIDA and continues to work that along with being part of our research team here at NowSecure. And so with that, what I'd like to do is hand over to David to introduce himself and carry us forward. David?
Hey guys, David Weinstein here. Thank you very much for being on the call. So I've been a reverse engineer for roughly almost 20 years now. I got started reverse engineering video games since I learned how to spell RTS, a real-time strategy game. So that's really what got me started. Previously a security researcher at the MITRE Corporation, and this presentation, I believe that to understand defense, you really have to understand offense. As the CTO at NowSecure, my team and I, we spend a lot of time reverse engineering applications, testing apps, and device security so we can help people close the vulnerabilities and protect their apps for the users. So it's just a little background about NowSecure. Mobile is definitely in our DNA. We started with mobile from day one, and it's always been our focus. We literally wrote the book on mobile forensics and have a dedicated team that you're getting a chance to meet today. The focus is just on mobile technology and the security research team. As we'll talk about today, collectively, we contribute to a lot of open source tools. FRIDA and Radare are two of those. We've also in the past contributed to the open source community, the Santoku project, and the Android BTS project, Vulnerability Test Suite. Finally, we kind of come at it from different perspectives, the research team. Some first having spent time in development and then moving to security, and vice versa, others starting with reverse engineering and then moving into development. And I think that's really important to the way that we look at and solve challenges in the mobile security space. NowSecure's mission is to save the world from unsafe mobile applications and to help our customers and the enterprises be educated on the latest mobile threats. So next, I'd like to talk a little bit about taking that attacker point of view. So to me, it's really about paying close attention to the details, and that means looking at everything from both the client and server perspective and really understanding sort of the deepest secrets of how a computer works. To me, it means asking questions like, are transactions being performed on the server, or is there some implicit trust between the client that's being handled by the client that ultimately puts your data at risk? It means understanding how to exploit incorrect code logic, and it means understanding really the intricate details of how a computer works. Many security people look at defense and don't necessarily think about the attacker perspective, but we do, and I think it's really critical to identifying and closing gaps in your apps and your business. So let's talk a little bit about the mobile attack surface. So we can generally group the attack surface into these few categories that I have up on the screen now. So data at rest, the code itself, data in motion, and the API backend. From the attacker's perspective, sometimes only one bug or vulnerability is actually needed to get that initial foothold. So when we look at the overall entire attack surface, you can see that there's just a whole lot there. It encompasses everything from privacy-related details, such as your GPS location, to cryptography-related attacks that compromise potentially the data at rest, to TLS issues that impact the data in motion. So how do you protect the information as it transits from your application on the device to the back end? And of course, we all have heard of different API backend or backend attacks that have received a lot of notoriety in news, and those are obviously very important as well. So this is the attacker perspective from a real-world perspective. So when we look at the real-world side of things, we have the application itself sitting on the OS. We have the frameworks. This is just sort of an iOS example. We have the frameworks that the application uses from the operating system, the native libraries that Apple implemented to support those frameworks and interface with, for example, with the hardware extraction layer, how the device ultimately renders things to the screen. You can look at the mock kernel and then ultimately the hardware. And when I look at this from the attacker perspective, I think, well, there's the application that has the potential to be malicious in nature, abuse the frameworks, the iOS frameworks, to sort of steal data from the user. You can have vulnerabilities in the native libraries, like traditional buffer overflows that are mitigated using various different techniques over the years that have come out, including ASLR. You can have race conditions that impact the ability for the OS to interact correctly, and you can also look at it from the network perspective. So in order for the application to be useful, it has to retrieve information from the back end, and usually that's via some network connectivity. You might be over WAN, it might be over the wireless network, and these are really the opportunities that we look at for where the attacker can sort of introduce or exploit a vulnerability. So usually it's really helpful to look at this from this perspective. Just a quick sort of review on reversing, so talking about the forward engineering process is really helpful from the perspective of understanding how to reverse engineer an Android application. So when we break down what this looks like, we have the forward engineering process is basically a lossy transformation, meaning that information during the compilation process or different stages of this can be irrecoverable. So we can actually lose information along the way. But the interesting part is this is ultimately what the attacker works with. They work with the final artifacts of that compilation process. So it's really helpful to understand at what stages you can introduce defensive techniques in that compilation process, but also to understand what the attacker ultimately has to do in order to reverse engineer that application. So here we have Java files running through a compiler, going to class files. We have the DX tool that turns it into DEX. And then ultimately an APK builder that takes native components, shared SO objects, native resources, and resources that get used to compile into the final APK that gets signed. So just to move on to the next sort of way of thinking about things, here's how I think about how we look at testing the application. So you can look at testing the source code. So this means you have access to the source code. Maybe you have ownership control of that application's code, but an attacker generally doesn't have that. So static binary testing is what's called black box testing, where you don't have access to the source code. You're trying to find vulnerabilities post-compilation, like I just showed you in that picture. You're essentially working with the final artifact, say an APK or an IPA on a device. And we're testing for third-party libraries that might have vulnerabilities. Everything gets included. On the second slide that Brian Reed shared, he showed that 50% of Android apps actually dynamically load code. And so it's interesting because static source testing and static binary testing might not necessarily catch those sort of things. And so that's why we look at this problem from the perspective of a holistic approach to coverage. And so we have static binary testing, dynamic binary testing, which is using techniques like FRIDA to do dynamic binary instrumentation and trace the functions and API calls that are being used by the application. And ultimately, we combine both static and dynamic binary testing to use something called what we call behavioral binary testing to look at heuristics, things that we've learned as analysts looking at many thousands of applications over time. And we've essentially codified those behaviors, those heuristics in software to try to detect them more from an automated standpoint. So we record with the dynamic binary instrumentation, look at the static binary results, and take all those things holistically to see how the application behaves, and ultimately compare that against those heuristics that we've codified. So we've talked a little bit about the attacker perspective, and I wasn't going to spend a huge amount of time on this, but basically it's really easy to think about defense and not think about the attacker perspective, but we do, and it's critical to identifying and closing the gaps. Today we're going to hear from two members of the research team on two important tools that are in a security researcher's arsenal. So just a couple of takeaways. Learn to think like an attacker. Mobile has a large attack surface. Many egregious attacks involve the network or man in the middle. Recommend using a combination of static and dynamic analysis to behavior applications under the attacker-controlled environment. This is basically you want to put the application under an environment that looks similar to an attacker, what an attacker would do. And with that, let me hand things over to Pancake Sergi to talk about Radare.
Hi, thanks for joining. My name is Sergi Àlvarez, but many people know me as Pancake. I'm a self-taught software engineer, and I have been doing free software and low-level stuff for about 20 years. Currently, I'm working at NowSecure as a mobile security analyst in the research team, but I'm also the author of Radare. This is a 12-year-old project started by me. It didn't get many contributions during the first 8 years. It's a free and open source framework to use solving many tasks related to reverse engineering. It's widely used by many people around the world for many other tasks, like vulnerability research, malware analysis, forensics, exploiting, etc. It runs in a large list of platforms and can be easily extended with plugins or scripts. For everything else, if you need any other missing plugin, you can use R2PM, which is a package manager that comes with Radare2 to install the rest of utilities. Focusing on mobile, Radare2 supports the two main operating systems, Android and iOS. You can install Radare2 in your Android phone using Termux or installing it from the Play Store. It supports all native file formats for this platform, like ELF, DEX, MBN, etc., as well as supporting assembling, disassembling, emulating ARM, x86, MIPS, and Dalvik code. On iOS, you can find R2 in Cydia, in a specific repository. It supports all the native file formats like Mako, FATMACO, DLD, Catch, etc., and understands all the Objective-C, dwarf, and resolve CS strings, references, and many other platform-related metadata, which are useful for reverse engineering binaries for these platforms. Most of the features of Radare2 are generic and are available on all the platforms, like the ability to do native and remote debugging using LLDB, GDB, or FRIDA, analyzing code, dumping process memory, etc. The console is the main user interface of Radare2. Its commands are mnemonic, so it takes some time to understand the logic behind them. The learning curve is steep and can be compared to Beam, JIT, or Perl, but just learning 7 commands is probably enough for most of beginners. It is possible to automate the script different actions by using R2Pipe, which is available for many programming languages, like Python, Node.js, Ruby, etc. There is also a visual and tiled panels mode, which let the users interact with keystrokes instead of having to remember commands. In this screenshot, you can see the graph view. There have been many user interfaces in the past, Gradar, Boken, Raggy, but none of those are maintained anymore. R2 ships an embedded web server that is able to serve a material designed from them, as well as opening the door to use remote R2 sessions. And now there is Cutter, a multi-platform Qt5 UI that is actively maintained and releases are in sync with R2. This is every 6 weeks. It's available for all these platforms. You can find it for Windows, Mac, Linux, but it's also packaged for NetBSD and Haiku OS. In this demo, I will show how to find and bypass the anti-jailbreak checks found in the damn vulnerable iOS app. You can download the IPA from this link, and you can see the screenshot, so you can get an idea more or less about the user interface of this app and the icon. And it's basically an app that has different checks and protections that are common in iOS applications for protecting. You can see that there are 2 buttons, one jailbreak test 1, and there is also jailbreak test 2. Those are the actions for activating the checks. So I will share the screen, and let's start with the demo. Okay. So we are in the webinar. We have the IPA in here. The first thing that we will do is unzipping the package. And if we open the main executable, which is found here, it will take 5 seconds to parse all the macro headers and extract the strings, etc. So now we are in the shell, and now we can go into visual HUD mode, which allows us to filter between different strings and symbols that are interesting for us. So we saw that the interface had some strings like test, jailbreak. We get the symbol, and we notice that there are 2 symbols. All of them are suffixed with the tapped name. So we can assume that all the tapped symbols are basically actions that are called from the user interface. So let's go back to the jailbreak sim and check the code in here. As we can see, we analyze the function and we press. We can check all the strings and call functions from this function. And we can see that there is a call to is jailbroken, and then there is another call to show alert for jailbreak test if jailbroken. If we go to this check, this is the show symbol is jailbroken. We can analyze the function, and we can check the graph. From here, we see that there are two basic blocks. One saying that the device is jailbroken, and another one saying that the device is not jailbroken. As we can see, there is no call before that. So we can check into this assembly that is basically taking one of the arguments to decide if we have to say if it's jailbroken or not. So we will go back. The first thing that we will do is basically copying the binary to get a copy of the original file. So we get a copy of downloadable iOS app in order to modify it. And we will reopen the file again in read-write mode. Then we can go back into visual mode, and we will do the first patch. So what we have seen is that there is a call to a function, which was in the test tab symbol. That is basically checking for the argument. What we will have to do in here is patching the line in here to avoid calling the jailbreak check, and basically return 0 in here. What we can do, the way that we can do that is basically writing this instruction, replacing the call to the check and just making it believe that it's returning 0. So the next call to the show alert, if it's jailbroken, it will be saying that the device is not jailbroken. So let's go back and let's check for the other callback. So we go for the symbol, jailbreak, S2, and we analyze the code again. If we check the output of this, we will see that now there are many more calls and functions. But the interesting thing is that all the logic of the jailbreak checks are in here. So you can check that there is like the file existed path, it's checking for application CD app. There is also default manager, file existed path for the mobile substrate, etc. So let's go back to the graph view, and let's try to understand the logic behind all these calls. So there is every check, there is two jumps, one which is the one correct, and the other one is when the check is not passing. So we can understand all the logic like a tree of all the checks. And if any of these checks fails, it will basically go to the left. And if not, it will go to the right. If we go to any of these small basic blocks that are the ones that are failing, we can check the disassembly and see that it's basically setting a local variable, the 1 in 19 offset, the value of W8, which is just an integer, and then setting it to 1. So the thing is that if we go to the bottom of the function, we can see that the local 19 variable is loaded from here, and then loaded into the W10 register. As long as we know that the 1 means that it's jailbroken, what we want to do is patch this instruction, the one that is loading this register, this value from this register, and setting it that to 0. So let's go back to this assembly, scroll down to the LDAP, and in here we will change this for a mop extend this. Now we have our application patched, and we can install the application in the device by just assigning it. We're using Apple Sign or any other tool available for iOS. If you're interested in learning more on this, I also suggest you to check out the website and join the IRC or Telegram channels. The community have written 2 books, and there are so many blog posts and YouTube videos you can watch in order to improve your knowledge on this tooling. I'm also organizing R2CON. This year will be the 3rd time. It happens the 1st weekend of September in Barcelona, and aims to be a meeting point for all the R2 users and developers around the world. All the talks in this Congress are recorded and will be published in YouTube as soon as possible. For future plans, they include basic maintenance improvements like speeding up loading times, analysis times, improving the quality of the analysis, stabilizing APIs, improving the bindings, etc. But except that, there's so many features that are interesting to have. For mobile, there are some interesting things that are coming. It will be probably available in the next month. It is supporting multi-decks, supporting remote Dalvik debugging, complete debugger for iOS, and native iOS and Android user interfaces for users to interact with R2.
Hello, everyone. So my name is Ole André, and I'm with the research team here at NowSecure. I'm a self-taught software engineer, and have been doing this professionally for roughly 16 years now. Another passion of mine is reverse engineering, which I got hooked on in 2004 when I started reverse engineering Microsoft's proprietary video codec used for Messenger's webcam feature. It took me 6 or 7 months, but I eventually managed to complete it and release it as open source, and it was known as libmimic. It was projects like this one that inspired me to create one-off reversing tools, and I started dreaming of having a toolkit that would allow me to quickly build new reversing tools for the task at hand. So in 2008, I started on the first building blocks on what later became Frida. Because basically reverse engineering tends to be, every problem is different, so one tool can't solve all problems, but if you have a way to build tools, that's the ideal, so you can quickly build new tools for the task at hand. All right, so a bit about what Frida is. So technically, it's a dynamic instrumentation toolkit, which essentially boils down to letting you debug live processes, meaning you add instrumentation into them that wasn't there before, because you can imagine it as adding probes or being able to attach an instrument to running processes and see what they're doing, to understand them and reverse engineer them. Being able to do this in a scriptable way is another one of the goals, and what Frida does. So that you don't have a shorter feedback loop, so you don't have to recompile your instrumentation code and then redeploy it and restart the application and so on, but you cannot do it all live. Another important part is that it's multi-platform, so you don't have to learn a new tool on every platform that you're working on. So currently this means quite a few platforms, but in the future we hope to see even more being added. For example, the QNX support wasn't there initially. That was an outside contribution. And Frida is also free and open source software, meaning that anyone can use it for whatever purpose. So, and like to demystify it a bit, I'm just going to show you quickly how it works. So you have your tool on the left. This is your instrumentation tool that you're building to understand the target process, which is on the right. So what you then do is that you ask Frida to attach to it, and then Frida will allocate some memory there in the other process. So it'll write some bootstrapper code there, and then next it's going to start a new thread in this other process, and that's going to execute this bootstrapper. And this bootstrapper is then going to load Frida agent, like shared library, which then is going to establish a communication channel back to the tool. And over this communication channel, you can then ask it to load scripts, which are pieces of JavaScript, and then that's up to you to define what those do. These pieces of script will then typically add probes to APIs that are of interest. And then those will typically feed back results over the communication channel, and that's what your tool will then present to the user or do something with. So without further ado, let's just dig right in and do a little demo. I'm going to switch to now my screen should be visible to all of you. So here I have a live stream of my iPhone that's jailbroken, and I'm going to now launch banking application that I would like to understand more about, to do some security research on. I launch it, and oops, this application is not supported on jailbroken devices. Well,
Hello, Ola, it's Brian. Just to let you know, we're still seeing the demo slide. You have the screen share is not active. You might try pushing the screen share button again, please.
Yep.
Thank you.
Sorry about that. So let's go back and repeat. So as you can see, hopefully now, I have a live stream of my iPhone that's jailbroken, and I'm going to go ahead and launch a financial application, a banking application, well, actually, I need to restart that application now. I'm going to launch it, and it's going to say, hey, I'm refusing to run on this device because it's jailbroken. So now, knowing a bit of having some experience with anti-jailbreak checks, there's a few things we can do. But before we do that, we're going to use Frida. So ahead of time, I have done pip3 install Frida, or easy install Frida, or some similar way to install Python bindings with the command line tools. So I can now do Frida ls devices. Shows the local system, this iPhone, and so on, and I can now use Frida PS to list the running processes, and I can specify capital U for USB, and here we go. We see all the processes on my phone. We can also add ANI for applications and installed, not just ones running. And here you see the ID of this application. So now we can use another Frida tool, Frida trace, U for USB again, F, say that we'd like to launch this application. And having some experience with this kind of anti-jailbreak checks, they'll typically look for files in the file system, and that boils down to LSTAT in many cases. There's many ways to do this, but it's one example. So let's just launch it, and here we go. And if you pay attention to this line here, it's actually checking, it's looking for /applications/cydia.app, and it's not doing looking for anything else that looks related to jailbreak detection. So this is the first check that's failing. So what we can now do is that if you look in the current directory, there's a handlers directory generated by this tool, and there's a subdirectory per library that we are hooking functions or putting probes inside. And here there's a file per function. So you can also use wildcards and like star stat or things like that. And then we can now go ahead and just edit this file on the file system. It has a bunch of comments explaining the API, but I'm going to remove those to make it more readable so I can explain it to you instead. So here you see some code that's going to be run. On enter means it's run before the function is called, and on leave means it's run after it's when it's returning. So one thing you might want to know now is like where in the application is actually this LSTAT call from. So we could go ahead and edit this and just do thread backtrace this context. This will give us an array of return addresses and an array, and that's just addresses. So we can then call map on that array to perform an operation on each element and turn it into a new array with different elements. So map debug symbol from address. So we'll take each return address and turn it into a debug symbol. And we're going to join these by new line and tab. So we're going to just save this and run it again. And now you'll see there's actually a backtrace here. So if we go and look for Cydia again, you can see that it was called by ns file exists a path, which was called by ns file manager file exists a path, which was called by the application itself. at this address, and then that was an internal function called by this and so on. Now the next thing we would do is that we would probably analyze this application with Radare, but to not make this demo too long, I'm going to just pretend that we have already done this. What I have figured out is that there's an internal Objective-C method that does the checking. So we can use the same tool again we can also, let's see here. I'm going to remove the backtrace because it's a bit noisy. -I. So we can add -m to trace Objective-C. So we can say the class name VPS utils, it has its jailbroken method. So let's launch. And you can see that it's called. And this one is actually calling LSTAT. So that confirms what we found through static analysis. So the simplest way to bypass this jailbreak detection is actually to just replace this guy. So what we're going to do is we're now going to use another Frida tool, the Frida REPL, the read a value print loop, and apply some instrumentation of our own. So we're going to do our c.classes VPS utils, and that one has a static method is jailbroken. And then we're going to do is jailbroken.implementation equals function, c.implement it's jailbroken. And instead of actually calling the original implementation, we're just going to return false. And we're also going to display a message, jailbroken, nope. So let's try this. So now we're going to use this other tool, the REPL. We're going to launch the same app, and we're going to load the script, and we're not going to pause on startup. So we're just going to launch. Here we go. Jailbroken, nope. And here we go. The app started, and we have now bypassed the jailbreak detection. Just one side note about Frida Trace that you saw earlier. You might wonder why it was able to generate this code here, LSTAT path and so on, and knowing that the first argument is a string and so on, and that's because it's parsing man pages on the system. So it may not actually be able to do this for you, but you can also always go in here and edit. One other thing to note is that you can change these scripts live while it's running. So if you have an application that keeps calling a function, you can actually modify the instrumentation while it's running. You just edit the file in the file system and it's immediately applied. In this case, this only happened on startup, so we had to launch the app again. Side note. So that concludes the demo. So if you'd like to learn more about Frida, I would suggest going to the website. The docs section has a lot of topics covered. We also have an awesome community on another website called CodeShare, the Frida.re, where people can share their creations, their instrumentation scripts. Because there's so many things you can do with Frida, like you can inject errors into applications, and you can observe what they're doing, and you can play with games. There's so many things you can do. So it would be a futile. I mean, wouldn't work to have the website cover every topic. So that's why we have CodeShare. You can go there to find a lot of existing examples that you can build on or use as they are. There's also a section on presentations by me and others. And there's David's awesome Frida repo, which has an awesome collection of existing things built on Frida and blogs, articles, and so on. And down the road, we have a book planned. So we'll hopefully have even more ways of learning Frida available at that time. And recently, we've had quite a few improvements in Frida, in Leather Frida. We have a brand new TypeScript support in Frida Compile. Frida Compile is a tool that lets you compile your script from multiple files and consume existing modules from NPM. If you're used to the Node.js ecosystem, there's thousands of existing modules that you can use in your Frida scripts. There are also some that are Frida specific. And now with the TypeScript support, you get code completion as well. So it's much easier. You don't have to look up the API docs of Frida all the time. You can just use the code completion in your editor. Another thing is that we have also way better iOS jailbreak compatibility now with 32-bit devices, which has been a weak spot for a while. And very recently, the Android support was massively improved. So we now support Android 8.1 and also x86. It should work a lot better on different ROMs, but there will always be there will be ROMs where it doesn't work, and we would love to have your help supporting those. But for now, I've been doing most of the testing on Nexus 5X, where it works really well on 8.10. So that's the currently recommended device and ROM to use. And also a Frida gadget, which is used for instrumentation on non-jailbroken devices or jailed devices. It's a shell library that you repackage the app to contain, for example, or somehow make the app load. That one is able to run standalone without launching it with a debugger by restricting the functionality a bit. So you can use that for building app tweaks. You can repackage an app and add some tweaks to it, and that can be quite handy. And also it supports bytecode loading now. So the scripts that you load and the standalone use case can be bytecode. So it speeds up the load phase. Another cool thing is that we have a driver for macOS that gives you system-wide spawn gating, meaning you can do early instrumentation of processes that are spawned outside your control. So any process spawned on the entire system, on a macOS system. That driver is optional, but if it's available, we will use it and use this feature. And down the road, we're hoping to see more Frida-specific modules appear in NPM, the Node Package Manager. You can already go there to look at some look for Frida-specific modules, but you can also consume a lot of existing generic modules for solving different kinds of problems. And perhaps down the road we'll have a native lockdown integration, so it's easier to use Frida on a jailed device. And another thing that's been requested quite a lot is kernel instrumentation, so being able to run Frida in operating system kernels like macOS and iOS and Linux. So that's also something we'd love to see. And recently, I was contacted by someone who was interested in porting Frida to NetBSD, so that might also happen soon or in the future. And there's also a Swift runtime integration in progress. So there's some cool things coming up. So with that, I'd like to hand it over to you, Reed.
All right, thank you, Ole and Pancake. Really amazing demonstrations and some really cool things that have been built. I think it's fascinating that both of you had this curiosity around reversing and trying to figure out how the apps work that led to some great open source tool projects. As far as I understand, you guys both have hundreds of users, if not thousands of users of your open source, so we encourage people to have a look at that. Now, we at NowSecure, of course, leverage Radare and R2 Frida, which is a combination of the two in our own product set. And so as part of every webinar, we like to share some best practices. So, David, maybe you want to sort of share some best practices from your research perspective as our listeners are here thinking about, where do they go next with their own initiatives?
Sure. Yeah, so as we saw today, each of the tools individually are very interesting and powerful. When you start to combine them, you get even sort of a force multiplier when you start to use complementary tools like static and dynamic analysis together. And as we saw, the process that Ole and Pancake took was largely a manual process, sort of discovering in line by line how to sort of defeat the jailbreak detection mechanisms. And that's something that we as a company have sort of done over the years and discovered many different types of jailbreak detection, different types of root detection. And so we have sort of built up a module of all the different types of detection mechanisms that can be thwarted. So definitely pay attention to the other open source tools that are out there. Man-in-the-middle proxy is an amazing open source tool written in Python that is very scriptable and can be used in an automated manner, and we definitely leverage it for automated testing. AndroGuard is a relatively old Android static analysis tool that has recently gotten additional open source contributions, and so is getting better every day. APKID is a tool by the team Red Naga that is up on GitHub and is using Yara to identify and create signatures for applications, APKs, so that you can use it to write malware signatures. I would definitely recommend checking out Caleb Fenton's blog, following Ole and Pancake on Twitter, TruePay. There's definitely a lot of great stuff that happens on Twitter on a daily basis. And I would recommend checking out the issue log for both Frida and Radare to see how you can get involved. Take a pull request. Usually the projects try to demarcate things that are relatively easy for a newcomer to get involved. And it's really a great way to learn how these tools work and to contribute to a great community. So definitely check that out. And finally, like I started at the beginning, just sort of looking at this problem as not just like something you want to do individually, but maybe consider how you want to start using these tools for automation. And we've been doing that for years. So definitely if you go down that path, take a look at some of the things we're doing. And I'll hand that back to you, Brian.
All right, thanks David and the team, and thanks to all of you for joining today. I think, we've leveraged open source substantially into our portfolio. The NowSecure platform now has a variety of tool sets that you can leverage. Auto enables you to automatically in 15 minutes test an application, custom application that you have built, and so that saves you a lot of time. When you want to do the deeper dive, our NowSecure Workstation product is really the workhorse to tear apart apps. It uses Frida, Radare, R2 FRIDA, and many of these other open source tools along with our own IP to really help you simplify and have a single package versus having to assemble all your own OSS technology in one place. NowSecure Intel, of course, hits on third-party apps in the cloud. So, whether you're using financial apps or social media apps or gaming apps or business apps, we scan those public apps and finally our services. So we have holistic solutions. We leverage open source widely. We'll continue to support open source and encourage you to think about commercial tooling as well. We're going to move into Q&A in just a second, but we speak frequently at events and attend events. So Snowfrock, I think, is our next event. That's in the Denver area, so please come join us. We're also speaking at a lot of the OWASP regional events. We do a rundown of the OWASP Mobile Top 10. Risk exposure, we also do a live open source tooling and cracking activity on stage using commercial apps and some of the open source tools you saw today. We'll also be at RSA. Many of you will be there. We'll be at Black Hat, of course, mid-year, so look forward to seeing you there as well. You can always stay up to date with that by looking at the events page. So we're going to transition now into Q&A. I will ask questions and then steer them to the appropriate speaker on the group. So I guess the first two effectively are for Ole. So the first one is, how is Frida different from Needle? And the related question is Frida compatible with Radare2 OS? So Ole, would you have answers for those?
Right, yeah, good questions. So about Needle is an example of a tool built on top of Frida and other things. So yeah, Frida is an engine that allows you to build tools like Needle and Objection and AppMon and so on. And regarding Radare2, yes, I've heard people using Frida with that, but I haven't done that myself yet. There are some quirks in the latest 11x jailbreaks and Frida, but the support is getting there. So it should be already working partially, but there might be issues with early implementation where that is a bit clunky. But yeah, I hope we'll get those smoothed out pretty soon.
Got it. So Frida is available for and compatible with many operating systems. So to be clear, both Frida and Radare are not just limited to mobile. There are other operating systems you can leverage them on. Actually, I'll steer the next one to David, and then others can answer. So, David, any thoughts of including Frida within an app? What are your thoughts on strategies? So no special permissions like jailbroken or rooted are needed. Should developers consider building Frida into their app?
Yeah, that's a great question. So Frida Gadget, as Ula mentioned, is totally possible to, in an Xcode project, include the Frida Gadget as part of your build process and start to expose and get some of the benefits of using Frida. That's definitely an avenue that's been available and is totally something that I think we've written a blog post about and shared that a couple of years back. In terms of it being used in our products, we've definitely looked at that, and it's something we're looking and we've been working on putting into our products. So basically, we have a different path where you don't even have to do that, actually. You just need to give us an app that's debuggable, and we can actually handle the rest from there. So there's no special requirements for those situations. And Ula can kind of speak to any other details on that as well.
Sure. Yeah. So one setting in Frida Gadget's configuration file, which is optional, is a one called code signing. And if you set that one to required, you will be able to actually, on iOS, launch the app without needing to launch it with a debugger. So you can actually repackage an app, add some tweaks to it, and have it be able to run on its own. The only restriction is that the inline hooking, the interceptor API, is not available, but you will be able to use Swizzling like we did earlier to play with anti-jailbreak detection or the jailbreak detection. So you'll be able to use a lot of Frida's API still, but on iOS, you have to to be able to do everything, you have to run it with a debugger. But because we piggyback on the debugger's ability to run unsigned code. On Android, it's much easier. So in that case, you can do everything. There's no restriction.
Got it. Okay. So then last question here, although people can ask, I think we'll have time for one more after this if someone would like to ask one. So for Pancake, so how do you feel about Cutter and the recent UIs for R2?
Yeah, I think that having a UI has been one of the main concerns for most beginners. I mean, most of the people who is coming to Radare2 are people coming from Windows, and these kind of users used to depend or are used to use a user interface. So having a graphical user interface is solving the problem of approaching this tool to these kind of users. And I think that it will open the door to understand and make R2 available for more users. So being able to use some workflows and improve the code base. I mean, I think that having the code base, which is the core project of Radare2, and having a user interface, separate projects is good because there is no conflict between them, and you can update Radare2 or change or include your plugins without depending on the UI.
Excellent, excellent. So as we move towards wrapping up, let me see, did we just get another one in? Hold on a minute, questions from the audience. Okay. So there's a question in there. Are both of these tools included in the NowSecure products? David, I'll let you handle that.
Yeah, the simple answer is yes. So in Workstation, you definitely have usage of R2 and R2 Frida, which we'll probably talk about in future webinars in greater detail. So R2 Frida is another open source tool where we combine sort of the capabilities of R2 and Frida together to try to get the best of both. And then in all of our automated processing, we leverage Frida quite a bit in order to get our dynamic traces and ultimately build up the heuristic model to solve the problems that I mentioned earlier. So trying to pull out the information needed to compare to our heuristics about what is the vulnerability, what's a risk, what is something that's going to impact your privacy. So yeah, definitely, and that's a big part of why we support these tools.
Excellent. All right, with that, I'm going to wind down our webinar. I want to once again thank our awesome speakers, David and Pancake and Ula, and we look forward to communicating with all of you in the future. As I said earlier, everyone will get this was recorded, and so everyone will get a copy of the slides and a link to the recording as well. Obviously, you want the recording to look at the live demo. If you're looking at tools, please give us a chance. The NowSecure productization of the open source provides you with a heavy degree of automation and additional tooling functionality beyond the standalone open source tools, and we're excited to continue to evolve those tools as well. We look forward to having the research team again. We're going to have another open source webinar here next quarter, and we'll be in touch on specifics around date and time. Thank you so much. Bye now.